This is the first session, and here we will get introduction with the Ansys software. And nowadays, a workbench is widely used in Ansys software because it is more comfortable. Now here you can see to the left side, there are many modules which are designed in workbench: design assessment, electric analysis, explicit dynamics, harmonic response analysis, linear buckling, then magnetostatic analysis, then modal analysis, then random vibration, and up to transient analysis. So here you can see the types of analysis over here, and the simplest analysis which is learned at the start, that is static structural. So static structural analysis is only used when the dead loads are acting on the component. So we will start here in the engineering data. The material of the component is entered here. So if you click on the engineering data, here you can see the list of the default materials which is shown over here. So this is the default material, structural steel, and the properties of structural steel are stored by Ansys software itself. And if you go to the engineering data source, you will see the lot of materials and their properties are also saved by the Ansys software. So you can choose the material from the engineering data source. Now we will come back to the project or static structural analysis. So first of all, you have to double click on the geometry, and you have to draw the geometry. A simplest geometry we will draw right now: a simple cantilever beam which is fixed at one end. So when you click on this geometry, it takes some time for opening. So it is showing here starting design modeler. So we have to wait for some time. Then there are the planes: xy plane, zx plane, and yz plane. So we will select the xy plane, and in the xy plane we have to enter in the xy plane, and then you can click on the sketching. You go to the sketching and you have to draw a simple shape. So of the rectangle, here it is shown a rectangular shape, and I will draw here rectangular shape. As this is a basic tutorial, I will not put the dimensions on this rectangle. Now I have drawn the rectangle. Simply you have to click on the extrude option. If you click on the extrude option, it will ask for the depth of the extrusion. So I will take here 10 meter. So 10 meter is the depth of the extrusion. Then click on the generate tab. So this is the generate tab, and I have clicked on the generate tab. And this is, you can see, a simply one a cube is generated. If you want to elongate this more, you can once again click on the extrude tab. Here you can, instead of 10 meter, you can type here 50 meter. Once again you can click on the generate. So this will be the modified cantilever beam. Now this is the geometry. Now we have to click on the model. In the model tab, we are going to generate a mesh, a meshing component. It will be representing number of elements on the geometry. It will be representing number of elements on the geometry. Now there is a one advantage of using workbench. There is no need to select the type of element. By sensing the shape of the geometry itself, your component will be meshed. So this is the good advantage of workbench. Now here you can see the mesh tab, and here right click on the mesh tab and generate mesh. So this geometry is getting divided. Now you can see the geometry is divided into number of parts, and each part is called as an element. And you can see, if you observe this, there is a uniform division. There is a uniform division, and this type of meshing is called as a mapped meshing in Ansys software or in finite element method. Now we will fix one side of this beam. Now here I will click on the static structural. I will select one side, right click on this, then we will apply a fixed support. Now this side is fixed and support is applied. Now on this surface, we left click on this surface, we will apply a force in the downward direction. So here you can go to the force tab, click on the force tab. Here define by vector, instead of define by vector you have to select a component and we have to apply the force in the downward direction. So in the y component, suppose I apply minus 1000 Newton force. So you can see the downward direction. The arrow is shown in downward direction. So here successfully force is applied. Now simply click on the solution and then click on the solve button. So you here Ansys is solving, it is calculating the stress strain deflection value on the each element on the each node. Now let us wait for a minute, it will show the result. So for if this is a simple problem, if you are solving a critical problem, then you need to use a higher configuration machine. Now a solution, insert, deformation and total deformation. So you can see over here the total deformation and the maximum total deformation is 0.01. You can see the value over here and its a unit is mm. So 0.01 is the maximum deformation and minimum deformation is 0. So this is the deformation value. If you want to see the stress, you can see the stress, equivalent stress. Now here you can see the 0.00084 is the maximum stress value and its unit is MPa. And if you want to see its animation, how it behaves, how this body is behaving, so you can click on animation and you can see the its a behavior. At the same time you can find the factor of safety over here. So here stress tool, this tab is shown here. Here I will click on the stress tool, then I will click on the safety factor and here you can see maximum is the 15. So this is a analysis by using elastic properties. Only Young's modulus is taken into consideration. If you want to go for the non-linear analysis, then you have to use the stress versus strain chart that we will see in the next session.